All right, ladies and gentlemen, so today we're going to be getting into our last, I believe, type of word problem for this chapter. And this is actually a review. We did this in 7th grade when we did our percent chapter. So today we're talking about relative error and percent error. Well, those two things measure or talk about how close is a measured value to the real value. Right? So for example, if I have a sheet of paper that's supposed to be 9 inches by 12 inches and I measure it and I'm measuring that it's 8.5 inches instead of 9, I want to know, well, how close is my measurement? This is used a lot in the sciences when you're doing experiments and measuring things. And it's also done a lot in like manufacturing where you might have a range of, you know, if you're making a part for something, you might have a range of what is acceptable for the size of that part. So the formulas are related to each other, but for relative error, we're going to subtract and we're going to take the absolute value. So it doesn't matter which way you subtract as long as you make it a positive answer, but it's measured, right? What did you measure it to be minus the actual? So how far away are those two numbers? And again, I'm putting it in absolute value signs. We're comparing that, so we're going to divide it by the actual, right? What are accepted, real value, whatever, however you want to think of it. But the one that you measure is only used once. The other number, what it's supposed to be, is used twice. Percent error just takes that value and it turns it into a percent by multiplying by 100. So we multiply the relative error by 100. Okay, that's the only difference. So you have to do all that work anyway. All right, let's see how we do this. Emily estimates the measurement of the volume of a popcorn container to be 282 cubic inches. So her estimate, this is the measured. The actual volume is 289. So we want to know what is her relative error. So relative error equals the absolute value. I'm going to just use letters. M minus A over A. So her measured 282, the actual 289, absolute value of that all over 289. So this isn't even really solving an equation, but it does fall under the word problems part. So if I subtract those two numbers and take the absolute value, I'm going to get 7 over 289, which you can leave like that. Oh, I'm sorry, no, you cannot. Helps if I had read. They want it to the nearest thousandth, so they want you to actually do the division. If they don't say that, leaving it as a fraction is okay. So this turns out to be 0.024. Her percent error then is just taking that number, 0.024, turning it into a percent by multiplying by 100. So 2.4%. The smaller the number, the more accurate your measurement is. Right? So if I get a really small number, less than probably 5% usually, it means that you're doing your measurements pretty good. All right, let's try another one. So Sylvia measures her bedroom for a new shade. Her measurements are 36 inches by 42 inches. Right? Those are the M's. Her actual measurements are 36.5 and 42.5. Those are the A's. Using the measurements that Sylvia took, determine the number of square inches in the area of the window. All right, so using the measurements. So area equals length times width. So we have 36 by 42. So 36 times 42 is going to give me 1,512 inches squared. Okay, determine the number of square inches in the actual. So now we're going to use our A's. Same formula. So we have 36.5 and 42.5, which gives us 1,551.25 inches squared. So again, this is measured, this is actual. Determine the relative error, right? And we're using it for our area, not just the actual measurement. So, relative error, measured minus actual over actual. Okay. So my measured was 1512, my actual was 1551.25, all over 1551.25. All right, so when I do my subtracting, if you're going to put this in your calculator, I would do the subtracting first, hit equals, and then do your dividing. And we'll talk more about that in class. Oh my gosh, what did I do? 155. 1.25 minus 1.2 equals divided by, and they again want it to the nearest thousandth, so that's tens, hundreds, thousands, so that's 3 decimal places, 0.025. Determine the percent error, so your percent error is going to be 0.025 times 100, so 2.5%. Oh, to the nearest whole percent. Again, not sure why I'm not reading today. So that would actually be 3%. All right, if the sides of a rectangle were measured to be 4.5 centimeters and 6.7 centimeters, the actual dimensions are 4.7 and 7. Find the relative error and percent error to the nearest whole percent and calculating the area. So we actually have to go through and do what we did up top, but we're going to do it just as one problem. So the measured area, length times width, is 4.5 times 6.7, which gives you 30.15. The actual, I shouldn't have switched color, sorry. 4.7 times 7, which is 32.9. So now we want to find our relative error. All right, so we're going to subtract 30.15 minus 32.9 divided by 32.9. So my relative error, again, I'm going to do the top first, and then divide it by the 32.9, and they want it to the nearest thousandth, so 0.084 this time. Percent error, and they want that one to the nearest whole percent. There it is. So we're going to take 0.084, multiply by 100. Rounding it is going to give me 8%. All right. You are going to try answers for the, oh, this is a little activity. Oh, I'm so excited I get to bring in M&Ms. Okay, we're not going to do this right now, obviously. So we'll do that tomorrow in class if I can get my butt to the store to get M&Ms. Anyway, any questions? Bring them to class. Have a good night.